Hello, I'm Sachin Lakum and I'm from Team 1 Group 4 from Computer Science 20 batch of Pandit Deendayal Energy University. Our team has developed an Android app on the Flutter framework. It is called CPU Algo and it is based on the CPU scheduling algorithms in the operating system. When you click on the app, it shows the splash screen of the app's logo, and this is our home screen. When you click on the app's logo, it shows basic information on what is CPU scheduling and why do we need it. The four sections are the CPU scheduling, and one is documentation and the other is about us. It consists of our team members' names and their roll numbers and our GitHub page information. So the first algorithm that we implemented is FCFS, or first come first serve. When you click on it, it takes you to the first page which shows basic information about the algorithm. On swiping, it takes you to the table page in which you can add or remove processes like this, and there is an IO burst button to add input output time to the processes. Now let's take three processes with these values, and when you click on calculate, it takes you to the calculation page which shows average waiting time, total CPU idle time, and the burst time, turnaround time, and waiting time and completion time for each processes, as you can see here. And on swiping, you can go to the fourth page which shows our implementation of a Gantt chart using a stacked processes. Now, while taking IO burst, let's take a few processes. Let's take 0. When I click on calculate, it shows the similarly the turnaround waiting completion time for each processes, and when you click on them, this time it will show processes with IO. The second algorithm which we have implemented is SJF, or shortest job first. Similarly to the last process, when you click on it, it takes you to the first page which shows basic information about the algorithm. The second page is the table in which we can add processes. Let's take 4 processes with arrival and CPU burst time as follows. When you click on calculate, it takes you to the third page and shows the calculation for the respective processes, and on the fourth page it shows the Gantt chart. Let's reset these values and go back to the second page, and let's take 2 processes with IO time. When we click on calculate, it shows the calculation, and on pressing run, we can see the Gantt chart for the 2 processes with IO time. The third algorithm which we have implemented is RRS, or round robin scheduling. The first page shows the information about the CPU scheduling algorithm. The second page has the table for adding processes and for setting the time quantum. Let's take 3 processes with these values and time quantum set to 1. When we click on calculate, it shows the calculation for the 3 processes, and on swiping right and clicking on run, we can see there is a faster implementation of the previously used Gantt chart on account of the 1 second time quantum. Now let's take 2 processes with IO. Here we can see that there are the calculation for the two processes, and on clicking done it shows us the Gantt chart for the two processes with IO. Last process that we implemented is SRTF, or shortest remaining time first. Here the first page shows the information about the shortest remaining time first algorithm. In the second page, let's add 3 processes with arrival time such as follows. On clicking calculate, it shows the calculation and similarly the Gantt chart. Now let's take the 3 processes with IO. On clicking calculate, it shows the calculation. Now let's click on done to simulate the Gantt chart. Now the documentation part of the app shows the documentation for the code we have written for each algorithm. As you can see here, it consists of the main code and its time complexity as well as its space complexity. This is done for each of the 4 algorithms.